Friends, I'm Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry and Mystery of Molecules. So today's our topic is thorium-based nuclear power generation and role of uranium-233 isotope. Actually, this topic is directly related to future energy generation and another thing, what is the role of India? So we will learn a very important thing. Please watch until the end with complete attention. Let's start. See, before going to details, I request you please look at the metal thorium. Thorium belongs to a community of element that is actinide, or this is actually a F block element. Okay, so this is this element, and if you look at this element little closely, its atomic number is 90 and its atomic weight is 232.038. From these you can conclude that the most abundant isotope is thorium 232, and actually today's top point of interest only on these isotope. So from this you can understand how much widely available it is, and since we are talking about this power generation, then it should be widely available, otherwise there is no profit of investing time on a less available substance. So let's learn this background. I think actually this uranium 233 belongs to it's a fissile isotope of uranium, means it can undergo this degradation, means nuclear fission automatically, and this is produced from thorium 232. That's why it is important that how much thorium 232 available, because this is converted into uranium 233, which is useful in the reactor now, and this belongs to the part of thorium fuel cycle. So during the radioactive decay process of thorium 232, energy released which is subsequently converted into electricity, means 232 to uranium 233 and subsequently into decay and it will produce electricity. So I shall come after some time in detail. So it has been used successfully in experimental nuclear reactor and has been proposed for much wider use as nuclear fuel. So this is the hope, student. And the interesting topic is that in 1947 it was informed that uranium 233 bred from thorium as a third available source of nuclear energy and atom bombs. Although personally I don't believe the arsenal of nuclear bombs, but it has tested. So consequently you can conclude that it could be used for nuclear energy generation. Now one important information, student, please remember there are three isotopes which can undergo fission, means fissile isotope for nuclear chemistry. One is uranium 235, one is plutonium 239, and the third one is our today's discussion uranium 233, which is produced from thorium 232. Okay, so since it is that much important, so what is its reserve? Otherwise it is pointless to discuss on it. Actually you have a huge global reserve, but right now thorium doesn't mine that much because right now this nuclear use of thorium is not like uranium, what we generate electricity nowadays from nuclear chemistry. Now, and if you look at the worldwide reserve, India stand first. Yes, India stand first in reserve, and that's very important because India is a developing country, very huge population and energy hungry. So if this technology is implemented for a commercial use, then that could be a blessing for this developing country and for the future also. I shall come in details in future. Now, so you can see the rank 2 belongs to United States and rank 3 belongs to Australia, rank 4 Canada. So this thing we have understood, and this 4 means the first 4 element stores huge amount of thorium percentage of thorium reserve worldwide. Now another interesting, student, is this information. Please remember, it could be asked in question, who has the largest thorium reserve? So question number 1, it is India. And another, what is the one of the MCQ question option could be given, monazite is a source of thorium nowadays, and since it is not directly mined, actually this is produced during the extraction of rare earth metal. It's a byproduct while mining of rare earth materials. Rare earth means lanthanides, and it has a huge use in means electronic industry, magnetic material generation, like that. So How this is prepared, since it is that much important, useful, and huge reserves are there. So first, thorium 232 is heated with neutron. Neutron has only 1 unit mass. So that's why this mass number 232 converted into mass number 233. The previous thorium has a half-life in 10 to the power 10 years. It's a very high half-life, although it's radioactive, and all are radioactive, student, this nuclei mentioned here. Now this thorium 233 is also radioactive with a half-life of 22 minutes. And subsequently what happened, it releases a beta particle or electron and produces proactinium 233. See, since it releases beta particles, so the atomic number from 90 it increases to 91. Okay, subsequently it releases to another electron or beta particle and produces uranium 233. Since beta particle released from nucleus, so this 91 increases to 92. And if you look at the periodic table, I guess it will be clear. You can see here, from this thorium to this thorium to this protoactinium 91, then goes to uranium, which is the widely used nuclear material, nuclear energy source material. Now, so we understood how it is prepared. And another thing, this has a significant half-life, 1,60,000 years. So it's easy to handle, you can consider. And what is half-life, by the way? The half-life, the time taken for a given amount of substance to become reduced by half as a consequence of radioactivity. Actually, in this case, we are discussing about radioactive half-life. So through any radioactive decay process, for example, in this case it's a beta decay, so the time needed for a particular metal, for example, you have taken 1 gram and ultimately it will be converted into 500 mg. How much time it taken for this uranium 233? This is 1,60,000 years. So that's why you can understand that it's a significantly stable. Now, and stable means, by the way, it doesn't mean that you can handle it anyway. Please be careful, please take proper protection while handling such kind of material, and I recommend please don't do it if you do not have proper government authorization or expertise. Now, nuclear fission, that is the thorium fuel cycle. This is important because this is the main topic of discussion. The first one atom of uranium means the fissile 1 atom of uranium 233 generate this 197.9 mega electron volt. It's a significantly higher, that's why it's useful. So some point, please listen. As a potential weapon material, pure uranium 233 is more similar to plutonium 232 through 239 than uranium 235. Okay, so these three nucleus which actually are fissile in terms of source, half-life and critical mass is a technical term. And another thing I want to say, that just listen, in 1994 US government declassified a 1996 memo that states uranium 233 has been shown highly satisfactory weapon material, because student, everything goes ultimately military power. Now, although it is only superior to plutonium in rare cases or circumstances. Now question comes that since it is not that much, second thing, what is the availability of uranium or this plutonium 239? Then it will be, so that's a complicated thing, we will come in future videos. It was claimed that if the existing weapons were based on uranium 233 instead of plutonium 239, Livermore would not be interested in switching to plutonium. What is the meaning? Means it's a satisfactory, it's efficient. That's why it could be accepted. By the way, what is Livermore? This is actually a Lawrence Livermore National Laboratory in Federal Research Facility in the place Livermore. It's actually US based national laboratory, you can consider. So, and another thing, in this case, sometime with uranium 233 there are some amount of uranium 232, and these can complicate the manufacture on uranium 233, but this is not that much problematic. That's why we can accept this issue that okay, we can adjust, we can use it still. Now So what happens actually, the chemistry, nuclear chemistry better to say. And remember student, this nuclear chemistry is a phenomena of nucleus. Chemical reactions are phenomena of outermost electrons. So please remember this thing, don't get confused. So what happens in this case, first this uranium-233, which is our focus of interest, bombarded with neutron, and then it is converted into another isotope of uranium-234, and it undergo 94% fission, and through fission what it converted into a xenon 137, and this is strontium. It's a, you may consider this is actually a heavy nucleus converted into smaller fragments, okay, and during that smaller fragments, along with that 3 neutrons. Now during this nuclear transformation student, one element is breaking into 2 smaller element, some mass loss is there, and that is converted into equal amount of energy. So that is the, so that energy is utilized to heat steam, and that pressurized steam is utilized to move a steam turbine, and in this way energy is generated or electricity is generated. So this is the overall process. So that is the main process how uranium-233 fission generates nuclear electricity. Now, so what is the future prospects of this thorium-232, or you can say uranium-233 worldwide? Thorium, from which this uranium-233 is breeded, is roughly 3 or 4 times more abundant in the earth crust than uranium. This is the game changer student, because nowadays the whole world is dependent on uranium for nuclear energy generation through nuclear fission process. But uranium has a particular limit, means it is not unlimited in our earth crust. So when it is going to finish, what is our hope? Our hope is its 2-step back neighbor, thorium. So that's our hope, point number 1. Second, the harmful impact or the waste is lesser in case of thorium compared to the uranium or plutonium based nuclear reactor, because you know nowadays it's become a huge problem or issue where we store the nuclear waste after the use of those nuclear fissile material, means nuclear fission material. After this new energy generation, some radioisotopes are there which are harmful, and we can't throw it in within soil or within our oceans. So we need to store, but how long we'll store, how much we'll store, so that's the issue, and those all are dangerous. If they mix into the soil or underground water, that could be a very big problem. So from that point, this thorium is also promising, and so that's why what is needed, technological advancement is needed to implement this technology worldwide, such that world get green, clean nuclear energy with respect to less harm of the environment, because ultimately if our environment is polluted, we can't survive. Now, what is the proof of this statement? What he told that this is safe, this. So this is International Atomic Energy Agency's data, and this is another newspaper cutout. So you can see that potential of thorium based fuel cycle constrain plutonium and reduce long-lived waste toxicity. So this is the proof that this actually, and this data is authentic because it is of International Atomic Energy Agency's data. Now fine, so the question is, why thorium based power plant is important for India? We have understood about the globe, India, because India has a huge amount of storage, and another points are, India do not have enough uranium reserve domestically. We do not have. So consequently, and another thing, generally when someone don't have the import, but it cannot import large scale due to non-member of NSG, means nuclear supplier group, due to NPT agreement or non-proliferation treaty agreement. What does this agreement says? This agreement is for not weaponization of nuclear material. Since India didn't sign this NPT agreement, that's why it can't be a member of nuclear suppliers group, and that's why lots of policies are going. If India supplies, India sign NSG, Pakistan didn't, so there could be geopolitical conflict, blah blah blah. I'm not going right now those things. So India didn't sign, that's why it can't be NSG member, so it can't get it can't import huge amount of uranium such that its nuclear power plant can produce maximum energy possible. So that is the thing. Now if you look at the India's current socio-economic condition, it has the huge population, 1.4 billion, second largest in the world, and it is actually a developing country. Consequently, it needed huge amount of energy because India is energy hungry. So consequently, we need energy, and because of the Paris Climate Agreement, we have to reduce our dependence on fossil fuels such that we can reduce carbon dioxide emission in our future. So consequently, we can't be completely dependent on fossil fuel, and we need to shift nuclear energy. But where do we shift? If we have fuel, then we can burn or we can process and we can extract energy. But since we don't have, but we have thorium, so that's the promise so that's why it is needed. India need to develop technology such that it can do this. Now I shall come. Now, the other point is renewable sources are not regular and can't be obtained 24 hours, 365 days. What do I mean? For example, if you consider solar power, it is available only in daytimes, and there are some places during the rainy season the energy production low, during the fog energy production less. So it is not 100% genuine, and we do not have 100% control over it. Even if you say windmill, a particular time wind is good, this thing, fine, we cannot, that's why we cannot completely dependent. Right now what happened, that this hydrocarbon based fuel plant or coal fuel plant are kept as a backup. Means when you have a less energy production but you need a significant amount, then this power plant used to supply energy such that a amount of energy stability or grid stability is maintained. Okay, so all this thing, since we can understand that we need nuclear, but with safe, and another thing, we need a supply. So that since India has the largest reserve, so that's why India should try to implement or develop technology such that this thorium based power plant can generate energy and supply India, that it can fulfill its demand. Not only that, India spends a huge amount of its foreign reserve for importing oil, or you may consider sometime coal, natural gas, so that thing also will reduce. Now a complicated question comes. I know this is a geopolitical game. So if thorium is so good, so reliable, widely available, then why this is not commercialized for power production? Simple question. I told this is a very good, very excellent answer. Why still not? Am I the intelligent person in the world? No, student, not like that. There are many people, but still, why it is not happen? Even why are we still running behind fossil fuel based sources? Because we have a huge amount of storage, and this amount is 3 times compared to uranium. So why we are not still running behind fossil fuel? We are making new fossil fuel based power plants, or don't we have enough money or research funding or research capability that we can develop this technology? I know all the questions are complicated, so I shall request student, please write your opinion on the comment box. What do you think? I do not have any answer, but I have a thought. Please don't consider me wrong way. Actually, I believe worldwide discussion needed on this topic, and for my side, based on my study, what we have learned, that for uranium, means whatever we are doing as a nuclear energy generation from uranium, what was the prime purpose on doing research on this nuclear material uranium? To develop atom bomb, not energy. When we realized that how much destructive it is, then people became aware. No, we don't want destruction, we don't want to destroy our earth, we don't want to destroy humanity. So utilize this technology or science for the betterment of humanity. That's why energy generation thing. So first is militarization, second is energy generation. So I guess now you have to understand based on your common sense what is the story. So this is the end of this discussion. Thanks for watching. If you enjoy, please like, comment, share. See you in my next video. Bye bye.